Cool. All right. Welcome everyone who is tuned in. I hope you can hear me okay. If you can, let me know in the chat. If you can't hear me, then I suppose we have some problems. And we'll also see what the delay in the chat is. Let's see, I tested this yesterday and the sound was good. So, okay, yeah, there we go. Cool. Alrighty. So today we are going to be soldering a Diavolino, which is this little board right here, and it is a microcontroller board that is based on the Arduino Uno, as you can see here. They're pretty much the exact same thing, except this one's slightly less sophisticated, for reasons we'll get into once we start building it. But the cool thing about this is that it's designed for you to be able to solder yourself and sort of teach yourself how to solder as you do it. So first things first here. One moment while I consult my list of things. Alright, so there's a bunch of tools that one needs in order to be able to do this, starting with obviously you need a soldering iron. That's this one right here. I have, in my case, I've put, it's hard to see, a chisel tip on this. Also comes with a conical tip. You can use either one. Probably, if you have a soldering iron, it probably has a conical tip. I like the chisel tip a little bit better personally, just because you can get right in there with it. So I'm going to go ahead and turn that on now. Temperature controlled soldering irons are preferred because they let you finally control the temperature at which you are melting your solder. Mine's set to about 375 C, which should be good for our solder, which is the other thing that you need. Sort of difficult to see here. Let's see if I can pan the camera. Nice. So what I have solder here, this is, let's see if I can take it out. I have some lovely, hard to see where the camera's looking. This is Kester solder, rosin core. It is 6337, which is the ratio of tin to lead. That's a good ratio. 60-40 is also a good ratio in terms of being easy to melt and easy to work with. I use leaded solder because we can use leaded solder here in the US. In other countries, especially in the countries of the European Union, you have to use lead-free solder, which comes in some other mix of materials. I hate lead-free solder. It's a pain to work with. It requires much higher temperatures to melt. It doesn't flow as smoothly, yada yada yada. But so this is rosin core solder, so it will have the solder, and then inside the solder is a little bit of rosin flux. Flux like this, which comes in like pen form. For those of you who I gave like a parts list to, I didn't put flux on there, and if you look at soldering tutorials, sometimes they'll tell you that you should have flux. And you might want flux, but the thing is, for the purposes of through-hole soldering on something like this, the flux that's in the solder will be sufficient most of the time. Where flux comes in handy is if you're soldering something that's like a surface mount part. So you can see this board here has a bunch of surface mount parts, and you can see the pins are all very close together, and the flux helps them as you're trying to solder that stay bridged. However, this is where I get into my general feelings about through-hole versus surface mount technology. So this is obviously through-hole in that there's a bunch of holes and we're going to put components through them. And the nature of through-hole is that it's the components are typically bigger and easier to work with. However, modern electronics these days are increasingly surface mount components, which are more or less impossible to hand solder. It's very difficult. You can see especially all of these little components on the side here. You pretty much need a microscope and a very small soldering tip to do them with, and even then these components are so small that the surface tension of the solder actually spins them around if you're not careful. So I tend to avoid soldering surface mount if I can, and I stick to through-hole stuff. And the good thing is, if we get to something, here's like another project I have. This is just a numpad mechanical switch. This is all through-hole stuff as well, although certainly there are mechanical keyboard kits that use surface mount components, and indeed this one was set up so that you could use either through-hole diodes or surface mount diodes. Why you would decide to do surface mount diodes on that, I don't know. But anyway, let's see. So I've covered soldering iron and the type of solder that you want. And then, oh yeah, don't get a soldering gun. You will see soldering guns. Don't get one of those. Get a proper electronics soldering iron. A soldering gun is more meant for like piping and things like that. Not good for the preciseness that you need here. Thickness of your solder, I don't remember what thickness this is, but you know, not too thick, not too thin. Very thin solder comes in handy when you're soldering surface mount stuff. Thick solder just means that you usually get too much solder at one time, which is a pain, and we don't like that. Then you have either your sponge, wetted sponge, or tip cleaner. I like the tip cleaner better. Basically what you do is, you know, the solder builds up on the tip of the soldering iron and you want to clean it off. In this case here, I've put some solder on here a little bit, so I'm just going to clean it off here. That way the tip is nice and shiny. As you can kind of see, it's hard to focus there. Like your tip's nice and shiny. I like the tip cleaner because it works better, and also the nature of the sponge with water on it is that it will cool the tip of your soldering iron and then it'll have to heat up again, and that's just kind of an annoyance to deal with as you are trying to get things done. And then other tools that you need, hand tools. Let me switch my perspective here. So we have the board and the parts and all that, but then other tools that you need. This thing here is called a quad hands. It basically has 4 little alligator clips, and you can use it to clip in. In our case, we'll be clipping in the board once we get to working on it, to this thing to hold it for us. There are devices, in fact this one's is a play on words of the name of third hands, which are these devices that are usually just this little mount and then like 2 alligator clips, and I hate them because they always fall over and they're a giant pain in the butt. So I recommend either something like this or something like where's my other one? A Panavise, which is actually a little vice grip thing that you can mess with here. This is one that I have. It doesn't work very well because it's a suction grip and it doesn't suction to anything I have very well anymore, but I do like it. So something like that to hold your work. And then other tools, we have diagonal cutters, snippy. So we're going to be snipping a lot of leads off. I like these little diagonal cutters, also flush cutters as they're called. These are the best ones. These are CHP 170s. And then needle nose pliers, miniature needle nose pliers, not the big ones that you'd find in like a home toolkit. These are used for holding parts, bending leads, doing all sorts of work. I have like a small one and then an even smaller one, things like that. And then things for when you inevitably make a mistake. So either solder wick, it's hard to see, let me get this thing out of the way for the moment. Solder wick, all this is a big bundle of braided copper, usually with a little bit of flux on it, and you basically use it to, when you mis-solder something and you need to get rid of solder, you heat up the joint and you heat up the wick, and the solder flows into the wick and comes off of the part that you're working on. And then you just snip off the parts that have the solder and toss it away. Or something like this, which is a solder sucker, where you basically heat up the joint and then you release it and it sucks the solder up, and then you dispose of it and go back and forth like that. Hopefully we aren't going to make any mistakes today. We'll see about that. So those are sort of the tools that you need. Then we want to talk about soldering. So soldering, people are somewhat intimidated by soldering because it's kind of an unusual thing that you aren't really taught. But it's actually pretty easy to do. I analogize it to basically gluing things together, because that's essentially what we're doing, except we're doing it with metal. The best thing about soldering is the different soldering joints. So this is a slide from Adafruit. Very basic overview of how to solder. So you have the process here. Oh, my wires are getting caught up. Too many wires. So basically you heat both the lead of the part and the pad on the circuit board for a period of time. You want them to both be heated. Then you add solder, and the solder will melt on contact. You keep heating until you get this nice sort of volcano concave mountain shape, and then you let it cool. Don't blow on it, it will cool off on its own, and solder cools pretty quickly. So at start and every few connections, clean tip of iron on damp sponge, apply thin layer of solder. That's the sort of cleaning process that I talked about. And then you have down here sort of examples of the common soldering mistakes that people make. This is the ideal. You want this sort of concave look to the joint. It should be nice and shiny, unless you're using lead-free solder, in which case it won't be shiny, because that's how lead-free solder is. You could obviously put too much solder on it when you get a sort of bulb like this. That's just too much, and you want to get rid of it because, well, it might bow out and touch other things or things like that anyway. It's just you try to have this nice shape. This would be not enough solder when you have just a little bit and it doesn't flow all the way around. This would just be a weak bond that could get mechanically broken. This is a cold joint, so basically if you were to like heat up the lead but not the pad, the solder would flow and bond to the lead, but it wouldn't necessarily bond to the pad, and so as the part gets moved around, you'd get an intermittent connection as the solder ball makes and breaks contact, things like that. Too much heat, if you have your soldering iron heat turned way up, you can end up scorching the flux in the solder, and it'll just make a kind of mess of it. You want to avoid that as well. That's why the temperature is important. And then a short here is like where you, or a bridge, this is what I often call it, is where you bridge two pads together. Obviously this could end up with you frying a component if you bridge, for example, the voltage input to the ground and just cause a short circuit or something like that. So those are things to avoid. And then this illustration is nice, but we like to see what it actually looks like. So here, this one is pretty good. This one is pretty good, although I'd say has maybe a little too much solder on it personally. This one here and this one here have way too much solder on them. This one, insufficient wetting on the pad, so you see it's bonded to the pin but hasn't really bonded to the pad at all. And here it's bonded to the pin a little bit and really not the pad either, so those are where you'd, in this case, for like this one here, you could just heat it up again and the solder would flow down and bond to the pad. This is a cold joint, so this would be a cold joint where you, if you didn't heat it up enough, you would basically melt some of the solder but not all of it, and you don't want to do that. You want it to be, you know, nice and consistent all the way around. And then a cold joint here with insufficient wetting on the pad. So those are that's your basic guidance for that. And now let's see. We'll get into desoldering once we need to do that. I went over the tips, the tip cleaner. Another thing that's very good to have is ventilation, because the solder has flux in it, and the flux will burn off, and it will create smoke, and you don't really want to inhale that smoke. So I have here, you can see I have a little fan here, which I'm going to turn on now. Hopefully it's not too loud. And it has just a little filter on it, so this will suck up the fumes and keep me from inhaling them. If you don't have a fancy little solder thing like this, all you need is a little fan or whatever just to sort of blow the fumes away from you. And that's sufficient in this case. And then, of course, you want to have a work surface where you're not afraid if the solder drips or you drop the iron or something that it's going to get burnt. So I just have this little silicone pad that I got off Amazon to work with. So like, don't do this on your nice Victorian dining room table or whatever without some sort of protection for it or anything like that. And then finally, we are working with sensitive electronic devices. They are sensitive to static electricity, and so you want to make sure that before you touch things that you could potentially blow up with static, that you're grounded either by touching something metal that's grounded, or in my case I have a anti-static wristband which is actually just connected to this fan, which is then grounded. You can just plug that in here. You know, if you work in a lab or something where you do a lot of soldering a lot, they'll often have an anti-static pad that'll have a little thing that you can plug a wristband into, and then you're pretty much good. I'm anti-static now, so I'm good to go. So with that, let's get started here. Let's look at the instructions for the Diavolino. So you can see this is what we expect it to look like when we're all finished. There's not too many components. There's the microcontroller. There's the oscillator crystal, which is what generates the clock signal for the microcontroller. There's several capacitors here, which are typically used in this case as decoupling capacitors, so they will help buffer any spikes in voltage from anything. We have a couple of resistors here. This resistor is a resistor for this LED here. This resistor, not sure what it's for. We'll see that in a moment. LED here, obviously this is usually like an indication LED that you can control with the Arduino. This is the programming header that will plug our programming device into once we're all done with it. And then we have some links here. These things that look like resistors but only have one black band are links. They're basically 0 ohm resistors, which means essentially all they are is a wire between this point and this point. The reason that they have this nice body that emulates that of a resistor and they have a single black band is that these are made more for automated equipment that would be inserting resistors like this. If you want to put a jumper in, you can feed in some of these links and the machinery can handle that okay. I'm not sure why they chose to include 0 ohm links in here instead of just some wire, because it serves the same purpose, but we'll get through that anyway. Yeah, so yeah. Oh, right, and there's a reset switch, little push button here. You notice this does not come, and I did not spec mine with headers, which would be pins or sockets that go into these holes here. You can order, when you go to order this, you can order the various kinds of headers. In my case, I have, see if you can see here, let me do, I have some strip headers here, which I will probably chop up and put into here. You could just get a big long strip of these pin headers if that's what you want, and then clip them to size. If you want socket headers, those you need to actually get in the right number of holes to match up. But in any case, either one of them, it's 1/10 of an inch pitch. So there's a 1/10 of an inch between each of these pins for all of these connections. Or you can just solder wires directly into it if you have an idea of what you want to do with this. Also, you will notice that on this board there is this whole section down here that's not populated. And if we sort of zoom into it, you can see what that is. So these are different ways that you can choose to power the Diavolino. It accepts power in a bunch of different ways, but you can only use one at a time because it does not have the sophisticated circuitry that something like the Arduino Uno has that lets you use either the DC input or the USB to power it, and it'll manage between both of them. This one, if you plug something in and then you plug something else in, you might blow it up, so be aware of that. But you can buy extra components to use a DC input, like that DC jack that I showed you. If you are using just a regulated input, so you have a DC power input that puts out exactly 5 volts, then you can just jumper that in to the microcontroller. and you'll be good to go. If you have a DC input that is not regulated, then you can put in a regulator here, as well as a capacitor, or a couple capacitors for it, and that'll do the regulation of whatever you put in, 12 volts, 9 volts, down to the 5 volts that the microcontroller needs to operate. Or there's this external V-in, so this Diavolino you can also order with a little battery case that has 4 AA batteries, and if you do that, then the wires run through here and basically plug in here. In our case, or in my case anyway, I'm going to run it off the USB power, which is why this link will be installed, because this connects the power line off the USB connector, or the USB interface connector, to the input of our microcontroller to run it at 5 volts. And this microcontroller that we have here is an Atmel AVR Atmega 328P, which is the exact same microcontroller that is used in the Arduino Uno, which is the whatever 800-pound gorilla in the room of little microcontroller development. So this chip on here and this one here are exactly the same. And in fact, they've taken what they've done for us is they've flashed the Arduino bootloader onto this microcontroller already. So once we get it in and install it, we can start programming this board with the Arduino software right away. Okay. So go to identifying our parts. Obviously we have the circuit board. We have the microcontroller. Then we have, as I mentioned, our 0-ohm links. Wire jumpers, as they're labeled here. Those are the things that look like resistors but have only one black band on them. We have our programming header. This is a right angle header with 6 pins. We have 2 strips of capacitors in varying amounts. The 18 picofarad capacitors, they've done a nice thing for us and put little black marks on top of them so you can tell them apart. Otherwise, you would have to get a magnifier and interpret the number on there. It does say 18J, which gives you an idea. And then we have our 1 microfarad capacitors. 3 of those are unmarked. We have 2 resistors. We have a big one and a little one. And so this one is a 1K resistor. See if I can zoom in here. See if it'll autofocus or not. Maybe not. Let's go to camera 2. Autofocus, please? Maybe? Maybe not. Anyway, let me go back to the display thing. So, skip a thing here. Okay, here we go. So it's easier to see here. So the resistor color code is a thing that even I struggle to memorize sometimes, but I know at least this much. Basically, you read it. The metallic color is usually the end, and that tells you the tolerance, like percentage variation. So this is brown, black, red. This means 1, 0, and then the red means times 1,000, so, or rather times 100. So this is 1K of resistance. And then this is a big resistor because this is a quarter-watt resistor, meaning that it can dissipate a quarter-watt of power. This little one is a 10K resistor, so it's brown, black, orange, and it's smaller because it's only 1/6 of a watt. So important to keep these apart, because if you put them in wrong, it could cause issues with the functioning, and you might burn out the lower power resistor. Let's go back here to what else we have. So we have the microcontroller. Let's see, we have the little button switch. We have the oscillator crystal, which is this little, which one am I on here? It's just this little metal can looking thing with 2 pins. And we have the LED. Most of these components are not directional, meaning we can put them in, whichever way we want, namely like the resistors, capacitors. The LED and obviously the microcontroller do go in a particular way, and we'll get into that once we get to those things. So let's see, do we have all the tools on the tool checklist? Yes, we have a soldering iron, flush cutters. I have a resistor lead forming tool, but you don't really need one of these, and I'll show you how I prefer to do it. Cable thing. I have a USB programmer here. So this is what we'll plug into our programming header once we get to that. And a computer. Obviously you're on a computer if you're watching this. Yep, there's the thing with the resistors. Okay, some hints on soldering. So this is a good little overview of what we're going to do. We're basically going to, for example, take our let's see here if I can. Nice. Look at this camera work. So we're gonna take our resistor and we're gonna basically bend it over, bend the leads over, then we're gonna insert it, and then we will flip it over, pull the leads out a little bit so that it holds the resistor in place, and then we'll solder. And we'll be able to do that with most of the components. Some of the components we won't be able to do that with, and I'll show you how we get around that. Then once you're done soldering, you snip off the leads, and there's an important technique with that to make sure that you don't fling leads into your eyeballs, because they will go flying off if you don't hold on to them. Okay, let's start with the 1K resistor. Alright, we're getting into it now. I'm going into the both view here. Check me out. Alright. See, I don't need this thing right now. Just get all of this stuff out of the way for the moment. And I want my work surface back. Quad hands here. You're zoomed in way over here. Let me unzoom. There we go. Alright. So what we're going to do here. So this board is nice in that it's very well labeled with where everything goes. Let's see if I can kind of get this to... Let me do this to the phone camera here. And get you a little bit of inside baseball here. You can kind of see what else is going on. But alright, so we have our board here. See if I can bring it closer and down. It's all labeled pretty nicely with what all is on it. So we got a good idea of where everything goes in the arrangement and whatever. Anyway, it says 1K right here, so that's where the 1K resistor is going to go. So I'm going to put this in here. And then we're going to take our needle nose pliers, like so. We want to kind of size up approximately where the holes are that we want, and then we'll just sort of grab onto it like so, and then I'm holding on to it with the one hand, and then I'm just gonna bend the lead like that, and then we can insert the one side into the board and try and line it up here on the other hole. Pull it back out again. Of course, you don't have to do this, you can just sort of eyeball it, which is what I usually do. So now we've bent over. I mean, you can also take the lead forming tool and you can line it up and go, and then you just put the resistor over top of it and bend it over. But in my case, I was soldering things that were too small even for this tool, which was not helpful for me. So now we're going to put it through. And then you'll see, as I just put it through, it's kind of loose. Well, it's actually in there pretty good. But you know, in other cases, if you have your leads in there straight, it'll just fall right out, which is not great because you want to turn the board over to solder it. So what we will do is put it in like so, and then we're just going to take the leads and push them over to the side a little bit, or a lot of bit, and that kind of holds it in place nicely. And now, finally, however many minutes in we are now, we get to do some soldering. So, let's clean our tip here, grab our solder, and let me see if I can get you a close-up here so you can see what I'm doing. I'll try and get closer here to this camera. While also unhooking my soldering iron from everything else. And away we go. So I'm just gonna tin this a little bit. That's what we call it when you just put a little solder on there. You want the tip to be nice and shiny, so basically get some solder on it. You can see maybe you can see the fumes coming off of it a little bit. Clean it again. If you leave your soldering iron on for too long without solder on it, it'll kind of, the tip will blacken a little bit, which is not great. Now we have a nice shiny tip. Kind of see my chisel tip here. So I'm going to take the chisel tip and I'm going to put the flat end of the chisel tip right onto the lead and also rest it on the pad. And then I'm just going to push the solder onto the lead. And it melts a little bit. And then you take your heat away and you just wait. And depending on the size of the solder joint that you're doing, you may be able to get in close, and you will, if you're very close, you have a magnifier or something that you can look at the joint, you'll actually be able to watch it solidify. So in our case here, where am I looking here? Diavolino. See, where you're looking and where I'm looking are two different places. Oh, there we go. Maybe. Oh, there we go. So there's our solder joint right there, and you can see we have that nice little mound shape that we want. It's a pretty good solder joint, if I do say so myself. And now we obviously want to do the other side, because if we don't, bad things will happen, or rather not happen, since it's not soldered in. And we're just going to do the same thing. I'm going to put my chisel tip right there. Let me know if you can see well or not, and I can mess with the camera setup, but it's hard to see what you're seeing and also do the soldering at the same time. The other thing to remember with solder is that less is more. You really don't want to use too much solder. You want to put in just enough, and that's usually all that you need. So we have this soldered in here now. You can see this isn't going to budge. Not as loose as it was before. The cool thing about soldering is that it is both a mechanical and an electrical connection. And solder connections can actually be pretty strong mechanically, so that's what we like about it. Essentially what we've done is we've glued this component to the board. So now we want to snip off these leads that we don't need anymore. And what I always do is I like to grab onto the top of the lead to keep it from flying away. Because if you don't grab onto the top of the lead, when you go to clip it, this lead will just go flying somewhere. And it'll either land directly into your eyes, or it will land, you know, like in your carpet, never to be found until you step on it. Something like that. Not ideal. So I like to grab onto the lead. The important thing when clipping leads is you want to clip them close to the solder joint, but you don't want to like actually clip the solder joint itself. So don't get right up flush with the solder joint. You want to go a little bit above where your solder is. It's kind of hard to see here because my hand is going to be in the way to hold on to. Let me see if I can do it left-handed. Not my best thing here. I need a second cameraman is what I need. Put it just above. I'm going to do it right-handed, that way I don't mess it up. Just above, and then click, pull the lead off, put these somewhere so you can dispose of them. And other times when we don't have links that we're using, I keep hold of these little leads to use as jumpers, because that's all they are. So you can hold on to those if you end up needing them for other things. And then I'm going to do this other one here. Clip. And now we have... This thing does not want to focus up close, does it? See if I can tell it to. What if I go to this one? Maybe. Oh, yeah, you can kind of see there. Very hard. I don't have like a good macro lens set up. You can see we have our nice little bridges there. So, let's see. Let's do this one, since this is the one I was mostly talking to. Alright. Let's look at the instructions for what it says next. We did the 1K resistor. Next up, it says, okay, yeah, we soldered it, cool. Now we're going to do the 10K resistor, the little one. And the little one, the little one basically goes, where's my pointer? I have a nice little, I'm using a spudger as a pointer here, I've decided. The 10K will go right here, where it says 10K. Very helpful. One thing that you might be able to see with the reflection is the traces on this board are kind of wild, in that they go off in sort of diagonal directions. That's a little bit unusual. That's sort of a design choice they did with this board. Typically, traces on printed circuit boards are much straighter. You can see here like parallel, and they move at like either diagonal or right angles. This one's kind of all over the place because it's supposed to be crazy. Yeah, I don't know whether I like that or not. I kind of wish that it would be more tidy. Anyway, we're going to do the same thing again. We're going to take our 10K resistor and we're going to bend the leads here. I'm just going to eyeball it this time. You know, we're doing it live. Nope, actually, I've done it too bad now. To be wider. Of course, the problem with that is that if you do bend these leads too much, they will just fatigue and break off, which is not great. So bear that in mind as you work on this. Push it through here. It's not nice and flush. Let's see. And then the nice thing that this big one comes in handy for is if I want to redo the joints here, I can just kind of flatten them out with this. This makes me feel kind of like a metal worker or something when I do this. So push that through the holes here. Honestly, the most difficult part of this is usually pushing this small component through the small holes. And then we'll flip it over, and I've already bent the leads out on this side, and we repeat. So we get that, and it's a little. If you've got excess solder, you know you'll get a buildup of solder on your soldering iron, and that's when you want to clean the tip. You want to have a nice, clean, shiny tip, free of a bunch of big globs of solder. Putting this on here, applying. There we go. Yeah, that's okay. Might be just a little too little. I don't like there to be too little solder. I don't like there to be too much solder. I like a visible mound. I don't like a kind of a flat, like puddle of solder. Then this one here. Just gently touch the solder to the iron, and of course it melts. And then you're good there. So this is good to go now. We're going to clip these leads. The Glengarry leads. You don't get them. Alright, so those are the resistors done. And remember, the resistors are not directional, so a resistor works the same regardless of which direction it flows in, so you can put it in either direction. In fact, most of the stuff on here you can put in either direction. This doesn't have any diodes, which I was kind of looking forward to talking about diodes. Well, it has a light-emitting diode, so we will get to talk about diodes and directionality of components. But most everything else here is, frankly, almost too easy. I almost wish this was challenging, more challenging, so with more to talk about. All right, so now we have the 18 picofarad capacitors. So farad is a measure of capacitance, which is essentially stored charge. 1 farad is an absolutely outrageous amount of charge, like absolutely ridiculous, way too much. So normally things are in terms of microfarads, nanofarads, or in the case of these things, picofarads. So this has very, very small amount of capacitance. So these 18 picofarad ones, as you can see here, are the ones marked with black stripes, and they're taped together. So what we're going to do, very carefully, just pull them out, ideally straight out from the tape band. There we go, got one. And then the second, just pull it straight out. And then these should not need any bending because they're set up nicely. And then they're going to go here. There's a little legend that is a little hard to see, but it says XTL, which is crystal, and caps. And the two capacitors, you can see on this here, go right above. There's these 4 little pads, 2 and 2. That's where they go. And of course, these are not directional either. Some capacitors, electrolytic capacitors, are directional. These are ceramic capacitors. They are not directional. They don't have polarity. So in this case, we're just going to put them through. And these are a good example of what happens. You can see here I haven't bent the leads at all. So if I go like this, they'll just fall out, which is bad. And that could have been really bad if they had fallen on the floor, which they didn't, so thankfully. So we're going to do this, put them through here. Oh my goodness. People say you need a steady hand to solder, and I am proof that you don't, but it does help. And then we're going to push the leads away from each other, lock it in, and then so that's one. Let's do the other one. Get it in here. Push the leads away from each other. Now, this will be our first challenge here because we have pads in close proximity, so we have to be careful that we don't bridge them, which is to say that we don't solder across the pads, which is not hard if you are following the methodology of less is more. So we're going to start here on the leftmost pad, apply some solder. Here we go. Take it off. Let it dry. Or cool. This is the one part of things with big leads like this is sometimes it gets hard to get your soldering iron in there. Put some solder right there. Take it away. Let it cool. If I had a big fancy thing to zoom in on, we could see, you could actually see, you can tell when the solder dries because it goes from very shiny to slightly less shiny. It's a bit like if you've ever done that thing where you put cold water into the freezer and then you take it out and you like whack it and it forms ice really fast and you can watch the ice form from like top to bottom. It's kind of it kind of looks similarly in that you can see the crystal structure as it solidifies sort of propagate down. Okay, we're doing this one here. That one's good. Finally, the last one. Get that one on just a little more. This one should be pretty easy because these pads are fairly small. If you were, for example, trying to solder in a barrel jack, you can see these holes here, these vias. Well, these aren't vias, these are holes. Vias are a different thing. These are quite big, so you would need a lot of solder to make sure that you bridge the entirety of that to hold on, and we can kind of see that here. You can see these, it's got real big terminals and then just a ton of solder. So that's really the case where you would need a whole bunch of solder to make sure that you were, in this case, it's not necessarily for the electrical connection, it's more for the mechanical connection. Since this is a big part that will be strained, you want that solder to hold it in so that it doesn't get yanked out. Another thing you can see here, it's really easy to tell. Let's see if I have an example somewhere of... maybe. So it's really easy to tell. It may not be easy on camera, but it's easy to tell when something uses lead-free solder versus leaded solder, and it's all down to the shininess. So you can see here, this kind of has a rough kind of appearance. It diffuses the light a little bit. Doesn't look quite as shiny as the soldering on the pins here next to this IC, which I did with leaded solder. So that's how you can tell. God be with you if you have to unsolder a bunch of lead-free solder things, like I did when I replaced all the keyboard switches on my keyboard, my mechanical keyboard. I had to unsolder all of the original switches, which were all done with lead-free solder, because lead-free solder, it requires a lot more heat, and so it doesn't unsolder as easily, and that's where you get, paradoxically, when you're trying to desolder lead-free solder, it actually becomes easier to add solder to it to help it melt, and then you take that solder away. That's what I end up doing anyway. Somehow that makes it easy. So let me double check here. Just got my magnifier. This is a nice tool to have, a magnifier. Not so useful necessarily here because these are big components, but if you're soldering smaller components, especially through-hole, magnifier is useful. But here, this just lets me see my solder joints, my handiwork, without having to put the whole thing up to my face. And they look good, so now I'm going to snip them away. That was the promised rant on lead-free solder. Apologies to those of you who are in the EU and can use nothing other than lead-free solder. Perhaps it will improve over time and become less of a pain to use. Leaded solder, so the one thing to know about leaded solder is that, you know, you're not going to necessarily, it's not dangerous, you're not going to inhale it. People think that because the solder sort of burns and has fumes that you're going to inhale the lead. That's not the lead that's burning, that's the flux, which is different. So you're not going to inhale the lead. The thing that it's important to do is when you're done working with lead-free solder, or leaded solder, you want to make sure that you wash your hands very thoroughly to get all of the lead that you might have on your hands from handling the lead-free solder, or the leaded solder, keep getting those confused, off of it. You don't want to inhale the flux, but the flux isn't going to give you lead poisoning. It's just going to give you other sorts of problems. Don't inhale the flux in general is the idea, so that's why you get a little flux absorber thingy here. Okay, let's see, the next thing, alright, we did, okay, so now we're going to do the other three capacitors. And I'm actually going to flip the board around here because this capacitor is up here and my alligator clip would be covering it. So we've got our three capacitors here. These are the 1 microfarad capacitors. I'm just going to take those, put them in. You'll see where they're supposed to be, there is basically 0.1 U, 0.1 U, and then there is one here for 0.1 U. Because these are actually 0.1 microfarad, not 1 microfarad. Whatever. Now, be careful here because there is a spot down here by the DC barrel jack for a 0.1 microfarad capacitor. We are not going to populate that. We need it for these other things. If we were going to install the DC power jack in a regulator, then we would want to get one of those capacitors and put it in there, but we're not going to do that. So this is sufficient here. And now we're going to just bend those leads. Bend those leads. Oh, I meant to talk about what is a circuit board anyway. This is a very simple circuit board. Basically all it is a piece of fiberglass with some layers in it. I think this one's only 2 layers, so it's basically fiberglass and then there's a layer of copper. The copper is etched away into the pattern of the leads on both sides, and then there is a resist layer, which is what gives the board its red color here, that basically covers everything except the pads that you want to actually solder, and then there's the silkscreen layer, which is the black and all the writing and things like that. That's more or less... I don't claim to be an expert on building printed circuit boards or quite understanding what they are, but that's more or less what they are. This is probably a 2-layer board. You can go all the way up to like 4 and 8, and God willing, even higher, I think. But those get very complicated, and you're probably not going to be hand soldering something that complicated. Got a little glob of solder on here, so I'm just going to clean my tip once again. You know, I feel a little bit like Bob Ross here. It's kind of a joy. The joys of soldering. Do this one here. Kind of get it to flow a little bit. There we go. That one was a little challenging because it didn't want to flow onto the pad. So you just have to be patient. That's the key thing here with this stuff is patience. By the way, if you're in the Discord and you're trying to message me, I cannot read the Discord right now, but I can read the chat. So. The Twitch chat, so please direct your commentary to the Twitch chat. Doing this one here. 2 down. Do this one here. Just apply a little bit of solder. So I know we have some folks who are going to try and follow along at home. Please let me know how it is going, or if you are encountering any difficulties, have any questions before we go on. And I am going to look here at the thing here and see what's going on. If I missed anything, okay, good. No one's posting in the Discord. It's good. I appreciate that. Dropped frames detected. Well, hopefully, even with the dropped frames, you can still tell what's going on. All right. Now let's clip these. So, yeah, with clipping leads, it's just, you know, you want to get close to the solder joint, not too close. You don't want to clip, like, way up here, because you don't want this lead sticking way out, because it, you know, if you have... Obviously, if you just soldered this like this and had all these leads sticking out and everywhere, then you could potentially sit this down and they would touch and short out, and then you would release the magic smoke from inside the microcontroller, and then it wouldn't work anymore. So, bear that in mind. Yeah, if you're doing a keyboard build, the soldering for keyboards is usually pretty easy, especially if all you're doing is adding in switches, because the switches are big, you know. With these big things here. I might just take this apart later, and that way you can see the switch pads or whatever. Although I have seen some solder kits for keyboards which use surface mount components, like I say. Those seem dumb in my mind. I wouldn't buy those, just out of personal preference and sort of under protest. But, you know, you do you. Next thing is the tactile button switch. And the nice thing about these little buttons is that they tend to have curved leads already. And if the board designer has done a good job, they should just sort of snap in. So it goes switch right in there, and then because of the shapes of the leads, it's going to hold just fine the way it is, so we don't have to worry about bending it. We do have to worry about soldering it, which is easy enough. I think, as you can see now. This is actually the component with the largest holes to solder that we've done so far. This one will take slightly more solder than the other components. And I'll tell you, you know, the way that you can tell if you've been inhaling the flux fumes is you will know, because you will feel a little bit funny. I don't feel funny right now, which is good. Well, I feel a little bit funny, but I always feel a little bit funny. But you will definitely know if you've been inhaling flux fumes. Alright, next thing. The LED. Alright, cool. Who knows what LED stands for? I have to wait for the stream delay to catch up. Alright. So an LED is a light-emitting diode. What the heck is a diode? We get an idea of what a resistor is. It resists the flow of current, basically slows it down. It's like a speed bump for the electrons. And those are passive components. They just sort of work, regardless of what you put across them. They will burn up if you put too much across them, but for the most part they will just work. Diodes are semiconductor devices, which means they actually have a little piece of silicon or some other semiconductor in there. Here are some diodes. These ones here are signal diodes. You can tell because they're small. They're little small boys. These are 1N4148s, standard signal diodes. I think they handle about 200 milliamps of current, so not a lot of current, but enough for signaling stuff. And this one here is a power diode. This is a 1N4004. This one can handle 1 amp of current, but it can also handle voltages up to 400 volts across it. And a diode is basically a one-way valve, a check valve for the electricity. So electricity can flow in this direction easily, but it will not flow in this direction backwards easily, at least at the normal voltages that you're expecting to operate at. Video froze. Oh, that's because... Here we go. Diodes. Here are the signal diodes. These are 1N4148 diodes. They're just little glass diodes. And then here's a power diode. 1N4004. You can tell which side is which because they have markings, which are kind of hard to tell. This one has black bands on the end that is positive, and this one is a black body with a silver band, which I cannot quite zoom in enough to get, but you might have been able to see that. And yeah, all they do is basically keep current flowing in one direction and not the other. Now, if you apply a large enough voltage in the other direction, you will burn out the diode, and it will go the other way. But you try to avoid that in most cases. An LED is just a light-emitting diode. It's a special kind of diode that, when current goes through it, it also creates light. But that means that it has the same directionality, polarity. Characteristics as a diode, so it has to go in the correct way. If you put it in backwards, it just won't turn on. And so you can see here there is a long leg and a short leg, and if you look end on the diode, it's hard to see on camera, but basically the diode or the LED is circular, except that on one end it's been sort of chopped. So it has a flat end, and that tells you which side basically which side to go on. I believe the chopped end is the negative side, but I can't remember. In any case, here they've done the work for us because they have both labeled the LED thing with the size of the leads to go on, and they've also made the pad. You can see here in the picture here in the instructions, there's a square pad and a circular pad, and we'll see this when we get to the microcontroller as well. So the square pad we're going to put the long hole into, and so we will just do that. Yeah, so the flat end is the cathode, which would be the positive side. That's the short end, the short leg. The long leg is the anode, which is the negative side. The way you remember that is that anode has N in it, so it's negative. Cathode has a T in it, which is like a plus sign, so it's the cathode. Positive end. So we're putting the long leg into the square hole, pegs into holes basically, and then we're going to hold that in place as we flip it over, and then bend the leads out like so, and then once again grab our trusty soldering iron and get to work. Now, if you were doing this without my color commentary, you would probably not need to clean your tip every time, because you would be going, you would not have such breaks in between doing each component that your tip would blacken a little bit as it's heated for too long, oxidize basically. But in my case, because I'm taking the time, I'm pretty much having to clean it the whole time. And then I'm going to tin it a little bit when it goes back. Hopefully that'll keep it from getting too burnt up in any case. I do know, I've known some people who have left their soldering irons on for multiple hours or even days, and that's a quick way to just burn up a tip real fast, which you don't want to do, ideally. Alright, so we've done that one. Now, here we are at the quartz oscillator. This is a 16 megahertz quartz oscillator, which I believe is the speed of our microcontroller as well, although it might be a fraction of that. I think it's 16 megahertz. So there's basically a little crystal in this little can that will vibrate at a rate of 16 megahertz. What you'll see here, I want to point out, on the board, and you can see in this picture here, for the crystal oscillator, this crystal only has 2 holes, but they provide 3 holes, and that's because some crystals only need an in and an out. Some have an in and an out and a ground as a reference, and so, you could put a different one in if you wanted to for some reason. I don't know why you would want to, but we're just going to put that in here. See, when I first started doing electronic stuff in 3rd grade, my teacher remarked that circuit boards always look like little cities if you sort of look at them up close, which I always sort of liked. Maybe that's why I like both soldering and SimCities. So then, here we go, pushing it out, clipping it in, soldering it up. Get it in there, nice and good. I'm just going to do, so this one has enough, but I like it to have a little bit more. Yeah, that's pretty good. Well, so the thing you have to keep in mind is that my dad is an electrical engineer, so I was taught to solder from a pretty young age. In fact, I soldered for his senior design project. He had a little board that went part of that, and I basically soldered the one that was not to be used except as a prop, but he's like, here, you get to solder this one up. So I think I did a pretty bad job, but he said I did a good job. That's a dad for you. Alright, crystal done. See what else here. Header. Okay, this is the fun part, because this header probably will just fall right out. So this is a little 6-pin right angle header. So we want the pins to come out like this, because what's going to happen is, once this is in here like this, we will take something like this and plug it in. And this is how we'll program it, is by connecting to this header here. This is a key difference between this board and the Arduino, is that the Arduino has extra hardware. As you can see, it has this little chip here. It's kind of hard to see, but it's a little surface mount chip, which is a USB interface chip that is basically this little chip here, and all of these electronics in this connector do all of the work that's on a board such as this one. This is an FTDI friend from Adafruit. In this case, somewhat difficult to find USB to serial chips in a through-hole format. They're almost all surface mount. You can see this one's fairly large. This one is real tiny. You can kind of see there. This is a quad flat non-leaded package, so you can see it doesn't even have any leads. So there's no way that you're going to hand solder this. You could try, but you would just be in a world of pain. As a result, for things like this microcontroller that are meant to be hand soldered, you pretty much have to use some other piece of thing, because there's not really a way that you're going to have through-hole components that let you do the USB interface. So that's what this header is here, is it's for connecting up to here, and that's how we will program and power it. Now, the key thing here is that we want to make sure if we do push this all the way down onto the board that we have enough clearance for this, and we do, so we're good to go. So we're going to push this all the way down so that the plastic part of this header contacts the board and is nice and flush. And then, again, if we flip it over, it will probably, it'll loosen up at least. So we want to flip it over, and then this is where something like this quad hands comes in handy. I'm gonna put this one here. I'm gonna put the board in, and then what I'm gonna do is I'm gonna bring this hand here, and I'm gonna basically use it to push the header up into the board and keep it in place. So that's basically holding that in place, because these leads here are frankly way too small for me to try and bend over to hold it in place. So what we're going to do is we're going to push up like this, and then we're going to solder one pin here. And when you solder one thing to hold in a whole thing, we call that tacking it, or tack soldering it. So now we've done that. So now I can take this away, and because it's soldered in, it's gonna hold the rest in there. If you have something that's very long, you might still want to. Oh, here we go. Jeez, thank you for pointing that out. Right. So let me recap here what I did. So I pushed this up here onto this, then I flipped it over, put it in here, and then I grabbed this part of my quad hand setup and pushed it so that this is sort of resting, the board is resting on the header, and then underneath is to hold this on here. So in this case, it's really only sufficient to solder the one thing, and I can take this away. If you have a whole bunch of pins all in a line, you might want to still hold it, because even if you solder this one in, the other end might come bowing out a little bit. That would be important if you were soldering in a whole line of pins like these. If you just soldered this end and then took your support away, then this might loosen up a little bit, and then it wouldn't be nice and straight, which could cause problems. But in this case, we're good to go. And we can keep on soldering and get the rest of them. Three, 4. Now you see, you can go pretty quickly with this. Not too difficult. 5 and 6. Get that on there. One thing that sometimes happens to me is that I end up getting a little over-eager, and so you get a big glob of solder on the soldering iron, but the pin and the pad haven't heated up yet, so it just sticks to the soldering iron. So you gotta put it back and let it heat up the rest of it. It's just a matter of heat, basically. Applied application of heat. It's basically what makes the universe work, actually, if you think about it. Don't think about it too hard, though. Okay, so that's that header installed. Very nice. And then we'll just give it a little test run here. Goes in nicely, doesn't interfere. You can see it lines up pretty well. So we're good to go for that. Now let's go. Remember next time. Aha! Time for the microcontroller. Very exciting. This is the literal brains and heart of the operation. We have our microcontroller here. Lovely Atmega 328P. The P stands for pico power, which means it uses less voltage than the traditional model. This obviously has to go in a particular way. And what you can see here, let me turn this off because this is reflecting, and then turn this on a little bit. You can see there's a notch on the left side here, and then there's a little dot. The dot indicates pin 1, and then the notch, they have helpfully silk-screened the notch. You can see it right there, the notch there, and then they put a square pad for pin 1. So that's where we're going to put it in. We're going to take it out gently. We're going to do it on the sides here because we don't want to bend the pins too much. Just gently pull the foam off. Try not to touch the pins too much. One thing that you might get is common with these components. In this case, the pins have been pushed in pretty well, so they're at like a 90-degree angle. What you might get, let me see if I have an example here real fast. In my box of miscellany. Yeah, so you might get something like this, where it looks more like a dead bug, and the pins kind of bend out a little more, and so you have to bend them in a little bit. Best way to do that, to make sure that they bend in to actually, fit in the board, is to basically take the component along a flat object and just kind of roll it in a little bit to bend all of the pins at once. You definitely want to make sure that you bend all of the pins at once instead of trying to bend them individually. Like, God forbid, don't take a needle nose pliers and try to bend each pin individually. That will just cause you a world of pain. Yeah. So basically, we're going to take this. We have the notch here. Line it up with the notch here. This one looks like it's good to go in terms of, yep, so it's good. We're going to push it in, make sure that it's flush. And then holding on to it as I flip it over. And I'm going to do sort of the same maneuver I did before. Going to grab this, use this to push it up in there. And then this component is a little longer, so I'm gonna tack sort of opposite ends here. I'm going to start at pin 1, the square pad. And then I'm going to do the opposite pin, pin 16, or pin, what is this? I don't know how many pins this is, 28, something like that. You guys can count, since you've got it up on your screen if you want. Yeah, don't drop an AMD CPU. That is, that's bad. So, got that now, so it's soldering at both sides, so I can take this. I could leave it if I wanted, obviously, but, whatever. Okay, so now we just got a whole bunch of pins to solder here, and of course these are close again, so make sure that you're using just the right amount of solder, because you don't want to bridge them together. Going along with the soldering. What I try to do is, I put, it might be kind of hard to see, but I think this angle is okay. My lighting setup is, well, yes, you should avoid dropping any CPU. Possible exception of the, what were those, the 486 DX2s that were like ceramic. Those might be strong enough that you can drop them, but they also might be weak enough that they'll crack instantly. Who knows? Let me see if I can move this light real fast. Oh. Ha. Doing it live here. This is the thing, is it's nice to have a whole soldering workbench set up, but of course that's hard for a lot of us. In my case, I just happen to have the second desk that I can use, but it's still sometimes a challenge because I just don't have a whole lot of space. Alright, clipping this on to this side now. Oh, ready? Nice! Problem too is I'm wired in like 3 ways between headphones, mic, and the grounding thing. So cool. It's a little shiny. It's kind of hard to avoid that, I think. Alright, pretty good. So, what was I saying? What I am doing... You can kind of see. Here I thought I was clever with the multicam setup, but ultimately it's much easier to do it to just the one of them. I am taking the chisel tip and I'm putting it right on the lead and the pin, and then what I'm trying to do is feed the solder to the pad or the pin and not directly onto the soldering iron, because if it's hot enough it should melt on the pin and the pad. If you go to just the soldering iron, then it might you know, glob up on that and not go to the pin and the pad. But yeah, I mean, you can see at this point we've done enough things, and soldering is pretty simple enough that we pretty much mastered it at this point. And now it's become something of a tedious chore. No, I'm kidding there, but I will say that, you know, if you buy something like, oh, where is one? Well, if you bought something like this is a little microcontroller board. You could easily solder in the header pins for these holes along the side here. You could do that in, I don't know, 5 minutes once you're well practiced. It doesn't take hardly any time at all. Let me look here. And I need a drink of water. We're still going, right? Yes, good, cool. Alright. Go to the bottom row here. Maybe in the future I'll rig up some rig to look down vertically. Though honestly, it's kind of hard to do like camera rigging for this kind of thing when both the camera's got to look at it and I got to look at it. And I like to look at these things close usually, because these are smallish components. Alright, and then I'm gonna, somewhat hard to tell looking side on what I've done here, so I'm just gonna take this real fast. Look at it. I like to look at it like this, and then you can see how well you've done. I think I've got some that have, you know, big mounds. I've got some that have small mounds. I think probably most of them are gonna be okay. I do see one here that has just a little bit, maybe 1 or 2, 3 maybe, that have a little bit too little solder. I'm just gonna add them a little bit. The thing you have to be careful of when you add solder is to make sure that you are heating the joint completely when you're adding solder, otherwise you will create a cold joint. Here, give a little bit more there. More there. More there. And more there. Once you start to get really good at this, you can tell what a like a good solder joint and bad solder joint look like just from the sort of reflection based on the angle that you're looking at. Because obviously the different shapes of the solder joints, you know, if it's like a mound or if it's flat, it'll reflect the light differently. So you'd be able to be like, oh, that looks, that's looks a little too shiny and not mirrored enough. That must mean that there's not enough solder. But you can see if we kind of look end on here. Fortunately, I can't zoom you in too much. Well, I can certainly try, can't I? There we go. That's kind of working. You can see the shapes that we're trying to accomplish here, more or less. And you can see they're not all perfectly consistent. It's going to be difficult to consistently get all of your joints to look exactly the same, because it's difficult to consistently dispense the correct amount of solder or anything like that. But we're good to go here. This is in place. And now, so we've done the microcontroller. Oh yeah, so do the pin thing. Yeah, this is just the little bit here about how to bend the pins over a little bit. Flip the board, 28 pins. Okay, this concludes the essential portion of the build. However, at this point, we're not done because we haven't hooked up the power to the board at all. So if we plug it in at the moment, it won't do anything. So now we have to decide our choice of power supply. And it says configuration options. The USB-V jumper connects USB to VCC, providing power from USB to your circuit. So that's the one that we want to do. Add this jumper if you want to power your Diavolino from a 5-volt USB to TTL cable. That's what I have. So that's what we're going to do here. Then you have some other options here for regulators. If you're going to use a regulator, you can add the battery box. The battery box goes in through the VN pins here. What we're doing is we're going to add this link here. And that'll be what we do. Yeah, so in this case they do, okay, you bring the things in, you put it solder. The reason you go through the board is to give yourself some strain relief. Oh, they cover socket strips. If you get socket strips, 2 6-pin and 2 8-pin, you can put them in, solder in. These female socket strips are what you would want for like Arduino Shield compatibility, because you could just stick something right on there. Or you can do I'm going to put pin headers on mine so that I can connect it to a breadboard with some jumper cables, basically. Okay, providing power from USB. One of the 0-ohm jumpers, and it connects across here. And that basically what that does is connects. This is the 5-volt input from the USB from the computer, and this will connect it to the power supply line that goes to the microcontroller. And then we'll do it like that, basically. Then there's other ways to do it. If you're using a regulator or a power supply like this that outputs straight 5 volts and it's regulated, then you can just go straight in with a bypass jumper. You don't need a regulator. If you're using an AC adapter that outputs more than 5 volts, then you need a regulator to regulate it down to 5 volts DC, which includes the little regulator component and 2 capacitors. We're not going to do that. And then, yeah, that's pretty much it. This is the schematic here. So we can sort of connect up what we've done here. So, this is the microcontroller here that we soldered in. And then we have, here's our crystal timer, or rather, oscillator. And then here's the 2 capacitors for that. There's a capacitor here that connects the ground and voltage source together. Then we had from the USB, there's a 10K resistor, and then there's the other capacitor that we put in, and then over here there is yet another capacitor that we put in, and there's the resistor and the LED that we put in, and the reset switch here also. And then this stuff, this is the regulator stuff if you were to decide to add it. That's where it would go. So let's go back up here. We're just going to put this thing in. Very simple. Almost done. Dropping some frames here and there. Know why that would be. Let me check my CPU usage. Seem to be doing okay. Probably just my internet, to be honest. So grabbing my 0 ohm links here, and I just need one of them. Can hold on to the rest of them for some other project, who knows. And then it says here there's USB-V, and then it says hookup, and that's what we're going to hook up across. Now, of course, we don't have to use this. I could use one of the leads that I chopped off earlier, but since they were so kind as to include these in it, that's what I'm going to use. So push it in there, pull it flush, push the leads out with my fingers, flip it over, and give it some solder. Looks good. Do this one. Looks good. Alright. Clippy clippy. You notice that we didn't clip the leads of the microcontroller or the header, and of course that's just because they are short enough that we don't really need to clip them, because they're not going to get bent into each other or anything like that. So, alright, so that technically completes this, in that I could now plug this in and program it. Of course, it will be somewhat hard to do anything with it apart from like turning the LED on without soldering pins or more things to it. So actually what I'm going to do here, I think I have enough of these pins that I can scrounge up that I'm going to solder them on here. I'm going to take the terminal strip here and then basically just snip right down the center of the plastic. That'll go in there. Could do it the other way too if I wanted. I could go upside down like this, and then if I had a big enough breadboard I could shove it into the breadboard that way, but that's a little bit silly. And this microcontroller is not optimized for a breadboard. It's just frankly too big. Something like this is made for a breadboard. You could put pins in that come out the bottom. Where my pins go. Like that, and then you can shove this into a breadboard, and then you can prototype to your heart's content. And if you don't know what a breadboard is, here's a breadboard. Basically, in these little rows, they're all connected together. So these are all connected, these are all connected, these are all connected, so on. So you can put a circuit in like this, and then you can connect up the various components to it. And it's basically a way to test your circuits before you solder anything down. Okay, so we've got this one in here. Let's see here. That one right there. Clip. Come on, here we go. And then I've got this one, which will fit nicely. Oh, look at that. That's already cut to size. And then I do have to, let's see here, I've got some 4 here, and then I need 2 off of this one. Of course, you can also you can get more advanced with this board if you want, because there is, obviously you can install the regular or whatever, but there is this section here. This is for a programming header if you wanted to program it using something other than USB, or if you wanted to like completely rewrite the bootloader that they've already installed. Now the problem with mixing and matching these headers is that sometimes you don't cut them flush, and so they conflict with each other. I'm just going to flip this around and hope that that helps. Oop, put it in the wrong way. Close. I think what I'm going to have to do here is very carefully try and trim the plastic off of this. A little bit. This is where you get to the artistry of electrical engineering, when you have to very gently try and remove small bits of plastic from things so that they sit flush. But you also don't want to remove too much plastic, because then the pin itself might come out of this, the plastic that it's holding here. And might be good enough. Yeah, there we go. It's nice and straight now. You can see. Alright, now of course it's going to be an absolute pain to try and solder all of these at once. I'm going to pull out just the ones that I can handle at a time. And do my thing again. In this case, what you would want, if you're putting in socket headers, you really want to make sure that they're lined up straight when you put them in. So, like, let's see, it's kind of hard to see, but this has some play in it. In order for an Arduino shield to go in, you really want to make sure that it's sitting flush. In my case, because I'm not going to put Arduino shields on this, it's not too big of a deal, but it is still very important that you put it straight. So I'm going to do that, and then I'm going to try and get this to hold it just so. Eyeball it a little bit, make sure that it's okay. It's close. It's not ideal, but it should work. Okay. Tacked one, and then I'll tack the other side. Okay, now we can take this away and double check here. It's leaning in a little bit. It's not exactly flush. So, let's see if I can correct that real fast. You should not touch the pins with your fingers, because the pins, of course, will conduct heat and burn your fingers, which is not ideal. You can see here there's a little bit of a gap on this end compared to this end, and also it's kind of bent in a little bit. Somewhat difficult to get this right. So what we will do, actually let me demonstrate for you. Let's see if we can desolder this properly. I'm going to take my solder sucker here, finger on the trigger here, there's a little trigger button, and then just heat it up, and then put it right up there, and boom. And it sucked up a decent amount, but there is still a solder joint there. So this is common of solder suckers, that they work well for sucking up a lot of solder, but not for sucking up a little bit of solder. So now what we're going to do is we're going to take our wick here, and we're basically going to shove it right up against there. And you can see a little bit, maybe it wicked up some of the solder. You'll be able to tell because the wick will go from a nice copper color to a nice silver color once it grabs all the solder, basically. Now the problem with desoldering is that you don't often, desoldering doesn't go as smoothly as soldering, and you end up putting a lot of heat in, and you really don't want to put a lot of heat in, because you can end up damaging the components, or you may even lift the pad up off the board, and that's real bad. You don't want to do that. So it's just a matter of being patient, as with most everything else solder wise. Let's try this. Let's do it this way, and let's see if we can't be a little clever here and try and heat it up. I'm gonna hold kind of hard to see. I'm holding the pins underneath with a needle nose pliers, and I'm going to apply heat to both joints and try and loosen it up, and then let it cool down again, and very gently. And there we go. I did a pretty good job of straightening it out a little bit better. So now we're, I think, good to continue. Truthfully, this is the hardest part of the whole thing that we've done today. Alright, that one's good. Let's get the other one in. Careful when you touch that header, because it's going to be hot. But if you don't burn yourself soldering, you haven't soldered correctly. Now I gotta turn it around. Try and use this thing again to straighten her up. So what I'm gonna try and do here is I'm gonna apply the solder and the heat, and then I'm gonna try and, once I've got the solder on the joint, I'm gonna take the solder away. But I'm going to keep heat on the joint, and I'm going to try and make sure that I'm pushing this in correctly before I take the heat away. And now, if I did it correctly, it's leaning in a little bit, but not as bad as last time, so we're just going to continue. No one said anything in the chat in a while. I can't tell if you're all still here or not, or if you all left. I wouldn't blame you. Alright, so that's the left side. Left side. There's not really a side. That's the top side headers. We'll do the other side. Because there is a little bit of a risk using these kinds of headers versus sockets, namely that when the microcontroller is on, these pins will be live, so if you were to bridge across them something accidentally, you could, you know, short things out, but it's just a thing to be careful about. Alright, gonna do this one here, same way as I did the other one, I think. Take that away, take a look, take a peek. It's a little off here, so I'm just gonna there we go. Just heat it up a little bit, enough for it to drop down. You gotta be careful there. So I heated up a little bit. I'm a little concerned that I may have caused a cold joint there. But this joint is sufficient to hold it in right now, so what I'm gonna do is I'm gonna solder the rest of them in as normal. And then we get to this one. This one's already soldered, but I am just going to heat it up and let the solder flow smoothly again to make sure that there's not a cold joint. And that looks pretty good. Now we just have the final ones. Let's do these 4 first. Really don't need the second thing, do I? I'm gonna hold in with the one. The only problem with these arms, of course, is, you know, the arms have their own sense of where they want to go, separate from the board and the pins. So, yeah, that's the only thing you gotta worry about. Apply heat here. That one's actually... Oh, those pins are actually bent a little bit. That's easy enough to fix. Just gonna take and apply a little torque. It's not that I soldered them in wrong, it's just that the pins, these are like pins that I've had lying around and they got bent up a little bit at some point, it looks like. Gently straighten them out. And then use this here. This one's a little challenging because there's only 2 pins, so it's a little difficult. Little alligator clip hardly has anything to hold on to. Good to go. Alright. Oh, hot! Very, very hot. That was... I had to burn myself at least once, and that was it, so... Good to go. Oh! No, bad job. Do we see the bad job that I've done here? You can see this one's nice and flush with the board, and these 2 are not nice and flush with the board. It's kind of hard to see. Let me see if I can put my fingers behind it. Oh! Don't drop your boards. You can see maybe a little bit of gap there, but you can also see the pins are coming down a little bit too far. So, we gotta handle that. Let's see if we can do that. Now, it gets hard when you're using one of these hand things, once you have enough things populated, to stick it onto some part where it's not gonna crush another part that you've already installed. So, what am I gonna do here? I'm gonna take the board here, and then I'm grabbing the pins with the needle nose, and I'm going to heat them up. Heat them up and try and straighten them out. Hopefully we can do this without needing to desolder, because that'll be just gravy if we can. Kind of a pain if we can't. See if we can try and get it across both. There we go. There was a little click there as it snapped into place. And now that I've heated those joints up, I want to take a look at them and make sure that they're still okay. You try to make the joint correctly the first time, so every time that you have to go back to it, you are increasing the risk that you might create a cold joint or otherwise mess it up in some way. And that looks pretty good. So with that, this is our finished product. This is a Diavolino, and we're ready to go off to the races with it now. I'm going to first thing we're going to do is when we turn this off, we're going to tin the tip a little bit with some solder. That will help keep the tip from oxidizing over time as it sort of waits in storage. And then when you heat it up next time, the solder will oxidize, but then when you heat it up next time, the solder will melt, and you'll just get it off with the tip. And we're going to turn that off. Going to rewind my spool here, so that's not in the way. Very good. And finally, turn this silly fan off. And now we're going to take the board over to our computer. Let's see if I can do this. Here comes the webcam. Welcome to my desk. Here's our board. And now we've got got our little, let me do it this way. You want to refocus or what? Here, come on. Maybe it will, maybe it won't. Oh well. We've got, this is a little SparkFun serial breakout. Nice thing about this one is that it's USB-C, and it's more compact than the other one. So what we got to do here is on this, it's labeled green, black. Those are the colors of the wires that would be there. And then on this, it's labeled green, black. We just want to line it up, or rather make sure that we've lined it up, and push it onto there. And it holds nice and tight. And then we can plug it in and hope that nothing explodes. Here we go. And you can see it is already running the blink sketch as it blinks there, but we're gonna make it do that anyway, just because we can. But not with this. This is the Arduino IDE. You can use it. I don't like it. What I like is Platform IO, which is uses Visual Studio Code. Let's see, can we do Control Shift P? There we go. Presentation. Oh, I think I have to install that. Oh, hey, there we go. Nice zoom. Okay, you can see things now. That's exciting. All right. So, Platform IO. Arduinos in the Arduino language are programmed in what is basically just a version of C++. There's basically custom libraries that are included by default in the Arduino RDE. In our case, we're including those with the Arduino.h. And then every Arduino program has a setup, which is things it does when it first turns on, and then a loop, which is just the thing that it does every time, every iteration, basically. And so this is basically how we do this. So we have the built-in LED. That's the one that's soldered to the board. I believe this is pin 13. Oh, is it not going to show me? Okay. I think it's pin 13 in the Arduino software here. So to set up, you set the pin mode for this pin to be an output pin. Could also be an input pin. I think there's all sorts of different modes. I don't remember. Is that going to help me? Oh. Usually Platform IO will give you little hints because it's Visual Studio Code, so it should have the documentation. Although it's not doing that for me at the moment. So we set the pin mode to output. Then in the loop we do digital write, so that's just 2 levels low or high. High is high voltage level, low is no voltage, more or less. So we start by writing high to this pin, so that turns it on. Then we wait for a second, and then we write low, so that turns it off, and then we wait for a second, and then we repeat. So that's all this is going to do here, and then I'm going to hit build. There are task errors, but we don't care. Success, okay, good. You see here we're using barely any of the RAM or flash, so you can have much, much larger programs running on here. And then we're going to upload. And hopefully this works. Do-do-do. Do-do-do. Auto-detected uploading. Programmer is not responding. I had this problem before with something else, but yeah, we'll just abort that and go back to the Arduino one. Let's see, we're on port COM4. That's what this is. All right, let's do upload on this one. Compiling. Might just be this program. I've never tried it before. But I don't think I have the other one installed either. I have two of the little programmers, which you can use. This is where you get into things like drivers and whatnot. So it should work. I mean, it's just doing it now, but at a different rate. And if we hit the reset button, it'll just restart. But yeah, once you've got all the drivers and stuff sorted out, which frankly I don't have the patience to do right now, you can then upload all sorts of different code to this microcontroller, and you can use it for all sorts of different things. So I've made a couple clocks with Arduinos, things like this. I don't know, you can do all sorts of things. I mean, these microcontrollers are the hearts of a lot of mechanical keyboard kits, so you know, that's the sort of thing that they do. A lot of these things end up running QMK for mechanical keyboards and things like that. So I think that's good enough. This is a soldering tutorial, not a programming tutorial, so I think we're gonna call it there. Thank you for joining me. I am going to end the stream now, and I'll upload this probably to my YouTube, and it should be available as a VOD as well. So thanks for tuning in. Let me know if you have any additional questions, especially if you're watching this later and you don't know what to do with something.